Hi, welcome to an Arduino tutorial from Robojax. In this video, we're going to learn how we can use this ISD1700 series sound recorder and player module and chip. We're going to test it with a push button and record something, make sure it works. Then record number two, I play. And then we are going to use Arduino to record audio and then play audio and also erase it. 1, 2, 3, testing, test. It will remove number 2 and opens place number 1. Also to announce, I have launched my Patreon account. If you want to support me, the link for Patreon is below the video in the description. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I've seen this module sold across the web on Amazon, on eBay, and AliExpress. I have another video from the same chip series. It's the small one. The link will be provided below if you want to see how you can record audio with Arduino. But this has multiple messaging and it's a little large capacity with better quality. But there was no information about it. It's made by WinBond. And this is a web page that I found. And I did not find anything on the website. So this module is supposed to be able to be programmed via SPI communication using these 4 wires, but I could not find any information about that. We are going to use these switches and I'm going to connect wires. I will going to explain that so we can use this and control it with Arduino to play, record, stop, and go to the next clip or so forth. Triggered. For example, this can record multiple messages depending on the type of chip that you get. For example, this can hold up to 75 seconds. It can continuously record, or you can record multiple messages until 75 seconds is filled. So this has enough memory for many applications that you can record alerts or the sound from a situation because it has built-in microphone here, and then also based on certain condition, or you can play audio. I've connected this speaker, but you can connect any other speaker that you have. 8 ohm will work with this. Let me explain the module. The main chip is ISD1700 series with different number at the end. Here we have 4 pins. This is 5 volts and ground. When you supply power from this pin, 5 volts. And then we have analog out and ground. This is where analog audio is outputted, which you can use for other purpose. Then this is the power pin where you can power adapter connect it, 5 volts if you're feeding it from here to the chip. At this side we have 2 pins here, plus minus, that's for the speaker. Microphone, condenser microphone is here. And here we have one LED which will tell us the status of operation of this device, this D. And we have these pins which will be used, this 4 pin will be used for SPI communication, ground 5 volts, and this is the analog N. So when you're feeding voltage, these 2, ground analog N and ground 5 volts. We have 2 separate grounds. And here we have these buttons here. This is to increase the volume. You press it, the volume increases until it cycles back to the lowest. This is feed through. When you press feed through, analog N, the signal that comes without any recording, it feeds out. Sometimes you need to do that. This is a play, record, erase, forward. Go to different messages. Length of the module is 53 millimeter by 49.8. That's 40 and that's 50 millimeter. But this jack is a little out. With the jack 52.3 millimeter. Or depth. If you're interested in the weight, It is 21.1 grams. I've connected 5 volts here, and then also a speaker is connected. We're going to first check the feature, then I will connect it to Arduino to control this. To record, we're pressing the record button and the light is on. Record number 1, record number 1. Now it has been recorded. To play it, we play.
The light is on. Record number 1, record number 1.
Very loud. We can reduce the volume. The speaker quality is very bad. And if I press record again, record number 2, record number 2. Now when I play,
record number 2, record number 2.
It brings number 2 and record number 3, record number 3, record number 4, record number 4, record number 5, record number 5. Now I'm playing it.
Record 11.
It will stop. It does not play all of them. So now I press it.
The light is on. Record number 1. Record number 2. Record number 3. Record number 4. Record number 4. Record number 6.
So when this does not play, if you press forward, it goes to the next message. You see this blinked. Now we must be at 7.
Record 7. Record 8. Record 9.
Now when you're at any record,
Record 10. Record 11.
now if I press erase, the record that is already at the status will be erased. When I press this, pay attention, this will blink twice. So now that record have been erased. Let's see.
Record 10.
So 11 have been erased, it went to 10. Now if I press erase, 10 should be erased. It should now jump to 9.
Record 9.
Yes, so 10 have been erased. Let's go.
Record 9. The light is on. Record number 1. Record number 2. Record number 2. 2.
Now we're recording something long. This is long, so we can change the volume.
Now we're recording something long. This is long.
Reduced. Reduced. When you press the volume, the audio increases slowly, and when it reaches at the end, if you press continuously, it goes down. So it goes up and down. I've spent quite some time experimenting with the project, writing the code, testing it, recording and uploading, so you can use it easily. The least that you can do for me is to click the subscribe button and leave the notification on. It's greatly appreciated. Thank you. Let's have a look at the data sheet. I was able to find this data sheet. WinBond multi-messaging system. As you can see, it shows 2007. Now it's 12 years old. And the operating voltage is 2.4 to 5.5 volts. And the amount of the range that you can select is 26 seconds to 120 seconds. Depending on the external resistor, using a resistor you can set the sampling rate from 4 kHz to 12 kHz. So using the resistor you can select the sampling rate, and here different model will have a different length of recording, a different frequency. The one that I have is ISD1700. I believe I checked all these numbers. 90 is 92nd at 8 kilohertz. So the 2 digit is referring to the number of seconds at 8 kilohertz. So mine is 601760, that's 60 seconds at 8 kilohertz. And we have even 240 at the 17240, which goes to 140 seconds. So automatic gain control, analog N, you can send the signal for the recording or feed through, and also you can connect external speaker. They have claimed 100 years retention, so it will keep your audio for 100 years, and you can record over 100,000 times. For the feed through, for play, record, erase, forward, these are the pins that you are interested. You see the dash, the bar on top of it. It means you have to set this pin to low or to the ground in order to activate this feature. For example, if you want to play, the pin that is labeled as play has to be connected to ground, or 0 volt will reach to that pin and play will happen. The same way record, erase. The most important one which you use it practically will be record current. When you record, it consumes typical at 5.5 volts, 20 milliampere, the playback 20 milliampere, erase 20 milliampere, and standby when you don't do anything is typical 1 microampere, maximum 10 microampere. And here is the speaker output power 670 milliwatt at 5.5. And this is a typical application, which I believe the one that we have is mostly like this. We are not going to see the block diagram. If you're interested, I will provide you the link. And to understand these pins, each pin is connected to these push buttons. This side is ground and this side is a pin that is functioning for that purpose. To understand the push buttons, the two pin on this side is connected to the pin of the chip, and these 2 pins on this side and on this side, these are all together connected to the ground. Same way for this, for all of them. Look here for the erase pin. You see we didn't see anything. If I go on this side, you will see the erase pin is connected to this pin. These 2 are together connected. And for this pin, the forward, again these 2 pins on this side are connected together. And if I do the continuity tester, this pin, the second pin is ground, and here from this side, so these are ground, the 2 large ones. I'm going to hold it here and see that this pin is ground, this pin is not. This among these 2, this is ground. I got these DuPont wire, one side is male, one side is female. Just clip it, and now I'm going to solder this to the board, and this side will be used for Arduino. Here I've soldered all the wires here to the volume, feed through, I've skipped it, play, record, erase, and forward. And on this side we have this male connectors, and here I've connected them all accordingly, starting from pin 2 to pin 6, here from volume to forward. Let me now explain the code for you. I've written the code. I've defined forward pin, erase pin, record, play, volume, and record LED, rec LED. These are the pins. The way that I've wired them, it starts from the volume accordingly on the board up to pin 6, all of them, and then I have pin 8 a little further distance. This is for record, so it will show us when the record starts, so you know to speak. In this line I've defined character with a called label. This is referring to a pointer, and we are putting these values so it can print actual text for us on the serial monitor. These are just a text to display on the serial monitor. Then inside the setup we are defining all these pins as output, and after that we have to set all the pins high initially so they are off, This is just printing the text. I'm not going to the loop, I'm just demonstrating it here. Then inside the setup, we're defining all these pens as output. And after that, we have to set all the pens high initially, so they are off. This is just printing the text. I'm not going to the loop, I'm just demonstrating it here. And I've written this code, record, and then a function with 2000 milliseconds. So this is when you record for 2 seconds, you just type record 2, this will record for 2 seconds. And here, for example, we wait for 2 seconds and we play this action, and then play. Inside the action, you put any of these pen arrays that we have defined here, play, volume, whatever you want, and the action will do that. For play, you just type PLAY, uppercase. It must be exactly the same as you have typed it here. And here is the two function. When you send action, that, for example, when you send the word play, PLAY, it will be a pen, which is pen number, for example, 4. It will come digital write, that pen, if I type 4 and then set it to low, that action will start. So the action will take place, and then we print the pen, the text, this is inside the quotation, and then we print the actual pen that you are taking the action, and it says active, so which means that pen is active. And then we give it a little time, 400 milliseconds, and then we set it to low after that, because the action will be executed during this time. And then we set it to high, and then we print this text telling us that it is now off, and then again we give it 400 milliseconds to turn it off, When we send the record, we just send the duration because we know the record pen is the same. Then we use digital write record. This sends the record pen, let's say pen number 5, whatever we have defined here, record pen number 4, and then we set it low. So this sends the pen 4 low, recording starts, and also we do this, record LED pen number 8 high, so the LED will turn on. We know that it is recording, and then wait for the duration, DUR, whatever you send, for example 2 seconds, it will wait for 2 seconds until recording starts, finishes. So this will turn off the LED, and this will turn off the recording, this line, record high, stop the recording, and then it sends the signal, the LED will be low, so we know the recording is stopped. Give it 300 milliseconds, and that's it. Erase the record, we just type here erase. And for any of those other action, forward, for everything, we just type whatever command that we have defined here, exact, uppercase. Remember, when you send erase, it will erase the last one that you have played or worked with. If you want to learn Arduino, whether if you're an electrical engineer, mechanical engineer, mechatronic engineer, or hobbyist or a researcher, I have an Arduino course that is structured from ground up, step by step, with all material, including the library, codes, schematic diagram, all in one place, will help you to learn Arduino very quickly. In no time, you will be able to build your own smart robot or mechatronic project using Arduino. The link for my Arduino course at Udemy is below the video in the description. This is a simple demonstration. I want to show you how the record and LED works, then I will demonstrate it fully. When you see the LED is on, I will start talking. 1, 2, 3, testing 1, and that's it, so the recording is stopped.
1, 2, 3, testing.
This is helpful because this LED will show any action that happens, this will turn on. But we want specifically a record LED to help us. And here is the demonstration, the first thing. And we first record for 2 seconds, wait for 2 seconds, and then play it. I've already uploaded the code, so if I open the serial monitor, there is a delay a little, but the recording at least will start, so I don't have to upload the code. It's very simple way. I'm clicking on I'm opening the serial monitor here. 1, 2, 3, test. It shows a little late, but
1, 2, 3, test.
so the record worked. Let's record a sound, 3 sounds. I'm uploading this, waiting. As soon as this turns on, I will record number one.
Record number one.
I will just open the serial monitor. Record number two. Record number two. Number two.
Record number two.
And I will open record number three. Number three.
Record number three.
Now this command will erase. This will erase number three. We give it a little time, and then we play. So this will play number two. Let's upload it.
Record number two.
That's correct. Now if I upload this again or run the code again, what happens is it will remove number two and opens place number one, because erase command will be executed and it will erase the last one. So this will erase number two, and then this will play number one. Let's open it.
Record number one.
Now if I open this again, it will erase everything, the last one even.
1, 2, 3, number one.
So this goes to the previous codes, and this will go to the more previous one, whatever I have. Nothing left now. This code will play the first sound and then give it a little time. So this is very critical. We have to know the length of sound and give it enough time to play, otherwise it will go to the next one. So this 3 means I know that sound is 2 seconds, so I give it 3 seconds, and then forward it will go to the next one. Give it a little time for the forward. It will be even 100 milliseconds. Okay, I put it at 1 second and then play. That will play the next sound, and then give it a little time, go forward with 1 second, and then play and give it a little time. Now let me upload this. See?
Record number one.
So then number two.
Record number two.
It plays, and then number three.
Record number three.
That's done. Now we are in number three. If I open the serial monitor, or as if I run the code again, it will start playing number three in here and then forward. Let's see it.
Record number three. Record number one. Record number two.
Now I wanted to talk about the volume control. Volume control has, because it has multiple steps, up to 28 steps, and except with that, there is no way to have proper control over that. You can run multiple times, you can run a for loop. So we used forward, erase, record, play. All of the features that this can offer. If let's say the temperature goes above certain value, you can just set this inside that function and say, okay, record for 2 seconds or for 3 seconds, whatever, as long as the memory allows. So number of recording depends on the length. So the total length determines, as long as you have the length, which is 70 seconds. For the 70 seconds, you can have 70 messages of 1 second, or you have one message of 70 seconds. It's up to you. And here, if we want to check the oscillator resistor, which is connected to pin 20 to the ground. So if I connect my probe to pin 20 and to the ground, whatever resistor I read will be the value that is setting the sampling rate. We have 14 pins here. That is 16, 17, 18, 19, 20. That is pin 20. And we have a lot of ground here, so I'm going to put it to this ground. I'm going to pin 20, and I will connect my ground to one of the grounds that we have here, multiple grounds. That is 15, 16, 17, 18, 19, 20. And as you can see here, let me put it on hold, we are getting 74.4 kilo ohm. And if you pay attention here, this is around 80 kilo ohm, and we're getting an 8 kilohertz sampling rate. Thank you for watching. This was how to use this ISD1700 series sound recorder and player module for Arduino. If you learned something and like this video, please thumb up. Please subscribe so you can get updates of my upcoming videos. If you have comment or question, post it at the comment section below. I try to answer and reply.